Alright, so this is going to be one problem done in two different ways with conditional probability. So conditional probability is when you've got certain conditions that need to be met in order to calculate your probability. So let's read the question. So a test correctly identifies a disease in 95% of people who have it. It correctly identifies no disease in 98% of people who do not have it. In the population, 1% of the people have the disease. What's the probability that you have the disease if you tested positive? So the first technique that I'm going to talk about is we're just going to choose a certain number of people and actually turn all these percentages into numbers. So I'm going to choose 10,000 people. It's somewhat of an arbitrary choice, but this choice turns out to actually give me nice whole numbers in the end. So if we take this choice and then start applying these probabilities to it, we can start filling in the table down here where we can say whether or not you have the disease or don't, and whether or not the test was positive or negative. So let's get rolling here. 1% of the people have the disease. So 1% of 10,000 gives me 100 people that actually have the disease, which leaves me with 9,900 people that do not have the disease. Okay, so next thing. A test correctly identifies a disease in 95% of people who have it. So if we take this, 95% of the people who have it, so we're stuck over here, and we are correct 95% of the time. So of these 100, 95 are going to test positive, 5 are going to test negative. Then we say, well, it correctly identifies no disease in 98% of people who do not have it. So we're over here in the do nots, and it detects 98% of the people who do not have it and say that they have no disease. So that's this guy right down here. So 98% of 9,900 is 9,702, leaving me 198 people who are going to actually test positive. So these people right here, this is a scary zone, and this is a scary zone. Okay? Now, let's take those off of there. Oh, maybe not. Okay, so what we're actually looking to do is, what's the probability that you have the disease if you tested positive? So what's the probability of having the disease given that I have a positive test? So if I have a positive test, that means I'm here or I'm here. So those are all the people I'm interested in. So the people I'm interested in, there's 198 people plus 95 people. And the ones who actually have the disease, that's the 95 people. And so if you actually do this computation, this comes out to approximately 0.324, which is 32.4%. And there's our answer. All right, now we're going to do the exact same question, but we're going to do this using a flowchart. I find the flowchart to be a little bit easier to use, but I will let that decision be really up to you when you do the problems on your own. So with the flowchart, we start filling in probabilities as we kind of read through here. So let's see here. We have 1% of the population has the disease. So if I'm a person, which I am, my chance of having the disease is 0.01. So my chance of not having the disease is 0.99. Now, if I have the disease, then my test will come back positive 95% of the time. So this arrow has a weight of 0.95, leaving this arrow to have a weight of 0.05. And if I don't have the disease, the test will tell me I have no disease in 98% of the people who actually don't have it. So I'll get a negative test 98% of the time, which means that 2% of the time I will get a positive test. Now with the flowchart way of thinking about this, we can now just fill in, if I land here, that's I have a disease and the test came back positive. So if I multiply those two guys together, that's 0.0095. Okay, if I have the disease and the test comes back negative, that is 0.0005, so it's quite small. If I have no disease but the test comes back positive, that's 0.0198. And if I have no disease and the test comes back negative, 0.9702. So what we were after originally is the probability that I have the disease given that I have a positive test. And now I can just read all of those appropriate things off of the right-hand side. So having the disease given that I have a positive test. So I have to have a positive test. So that's here and here. So that is 0.0095. Or I'm in the group 0.0198, and actually having the disease and being in that group is this guy, so that's 0.0095, and lo and behold, this comes out to be approximately 0.324, which is 32.4%. Same exact answer we found last time. So I hope this helps. Please rewind, pause, play this over and over again. And of course, there's lots of other questions that you can ask about this particular setup. So go ahead and ask them on your own. Good luck.